Okay, so welcome everybody who has just joined this live stream. I'm Tommy Mester. This is the next edition of the Data 36 live streams, and I will talk about a few data science projects I've worked on in 2022, more specifically in the last quarter of 2022. And I think that these projects might be very interesting for you if you are an aspiring data scientist or a junior data scientist or even a practicing data scientist, because I've learned a lot of things myself. And anyways, I will get started. And just one last time, let me mention that we will have a Q&A part at the end of this webinar. So if you go to data36.com/questions, you can ask your questions regarding this webinar, regarding my projects, regarding what I've shown you in this webinar, but anything else regarding data science, or you can ask any questions that you think that I could be answer. And also let me mention that this is a quiet, in some way, a bit more advanced webinar. So we will focus on what I learned. Well, I consider myself somewhere between data scientist, between the mediocre and senior level. I would not say I'm a senior, but I'm somewhere between mediocre and senior level. And so obviously my findings are interesting on this level, but if you are an absolute beginner, or you are someone who has just started his or her journey with data science, I really recommend my course to learn the basics, the Junior Data Scientist First Month course. And of course, this is the course that will be launched right after this webinar. So this webinar is sort of the launch of that course as well. So check that out. It's data36.com/JDS. I assume that you have already heard about this course, so I won't talk about this too much, but if you haven't, go ahead and check it out, data36.com/JDS, the Junior Data Scientist First Month course. I think it's a pretty cool course that will give you all the basics that you need to know as a junior data scientist in a very practical way. So let's focus on the main topic of this webinar, few data science projects I've worked on in 2022. And actually I will highlight two things, or two projects, and I cannot name names because I signed NDAs, so I cannot really tell you what these companies are, unfortunately, and I cannot give you very specific context, like what is the exact field that these businesses are working in. But even without that, I think this will be quite interesting and useful for you. I can tell you that one business that I will show you, or that I will talk about, is an SaaS business, which stands for Software as a Service business, and the other one is an e-commerce business. I mostly somehow, during my career, I almost always worked with these type of companies, like Software as a Service businesses, mostly startups, and e-commerce businesses, which is another very standard business type. And I think that for these two business types, data science and analytics is especially useful, and it's almost an immediate business value for them to work on data science projects. So probably this is the reason why they are the leading fields within data science, and maybe that's why I have so high ratio in my portfolio, in my client portfolio, from these businesses. So I mostly work with software as a startup businesses and e-commerce businesses, and I brought these two types of companies in today's webinar. And some stats. So as you know, working on data science projects, or as you might know, working on data science projects is not a full-time job for me. I have my online courses that I manage at data36.com, so that's a big part of my time. I write my blog, I have a podcast, but on the side I still work, let's say, half of my time on data science projects, because I love data science and I want to work in this field, also because I want to continuously learn about this field. So um, they say that those who teach can't do, or something like this, and I don't want to be that type of teacher who only teaches. And so here are some stats, how many hours I've worked in Q4 on data science projects. So my work hours were 150 hours, which is not a lot, but like weekly 10 hours that I worked on data science projects. The lines of code that I wrote is around 1,200 lines, which is interesting because if you do this calculation, you would say that I wrote like 8 lines per hour or something during these projects. But of course, this is not true. It's not because I'm this slow with typing code, or I'm not this slow with coding. It's because these projects involve a lot more things apart from coding. And of course, I sent a lot of Slack messages. I sent not so much emails, and I kept the meeting hours down. And I would say that these are very low numbers compared to other projects, and this is because I'm really focused with communications. But even so, around 30% of my time was communication throughout this project. And many other things came up. I will talk about this, but so just so you know that when you work on data science projects, coding is like not necessarily 100% of your time. It's not even, I think it's not even 50% of your time. Anyways, these were some stats. At this point, I think some people would ask, how did I get clients, or how do I get clients? And it's hard, it's hard to answer, or I cannot really, I'm not that type of course creator who can give you like a specific way of how you can get clients. If you take a freelancing class or how to build your own business class, you will find much better answers that I can give. But for me, I can talk about myself. For me, it was mainly self-branding. So as you know, I write the Data36 blog, and I do a lot of guest blogging, even on bigger blogs like Stack Overflow or other analytics blogs. And so by writing articles, people know that I'm in this field, and sometimes they reach out, and this is pretty much how I get my projects. The other one is from my professional network. So I talk to other data scientists mainly just for fun. So we have coffee, or we talk on Zoom just to share our knowledge with each other. I talk to other fields professionals. Sometimes I go to online conferences, and with that I built a network throughout the years. Again, this was like, I started this like 8 years ago, that I started to build my network and self-brand. And it's sort of organically built up throughout the years. So it's not some secret recipe I can give you. How do you get clients for data science freelancing? It's a long-term process, but of course there are these business gurus who can help you with it, and with their courses you can find maybe some shortcuts in this process if you want to freelance as a data scientist. But anyway, if you took any of my courses, or if you have read my freelancing article, I usually recommend that as a junior you do not start with freelancing. So as a junior, your best bet is go to a company full-time, learn everything properly in a safe environment, and after that, when you start to go towards the mid-year levels, then you start freelancing. But that's another topic for another day. The legal parts, because this is always a question that I get, I just quickly want to answer these ones. That of course, as a data scientist, you sign, even if you are a freelancer or a full-time employee, you have to sign very, very serious NDAs, non-disclosure agreements, so that you won't leak out anything about the findings, about the data or raw data. So you cannot leak out anything about the company, because that could hurt the company, and of course that's not really good for them. So they make you sign very strong NDAs, and I encourage everyone who starts freelancing to actually sign these NDAs, because once you sign that gives the company a way to trust you with their data. And once you have signed that, you can tell them that, okay, I signed the NDA, please give me all the data tools you use, and help me to get started fast. That's usually an issue when you start freelancing, like getting the data, but signing an NDA can help. Another thing that I do, and I don't know whether this is the right way or not, that I don't work on an hourly rate. I work in a minutely rate, which means that if I work, I don't know, 78 minutes during a session, I put it in a spreadsheet and I invoice 78 minutes and not 2 hours to my clients. There are people who do this differently. It works for me, and my clients pretty much like this, so I went with that. Okay, let's focus on the findings, on the data part of this presentation. And before I brought you like a few mosts, like the most interesting finding or the most exciting tool I learned. But before that, I want to give you a few highlights as well, or a few high-level findings. So the first one is what companies want, and this is not something I learned last year. I knew this forever, but I realized this last year. So companies with data science want two things: more money, and if they step back from more money, they want more user/customer success, which means that they want good for their customers, they want good for their users, they want their users to become successful via their products. But on the long term, this will lead ultimately more money to the company, right? Because then the users will stick with the company, they will like what they get from the company, and they will pay for that product. But ultimately, companies always want these two things: more money and more successful customers or users. And this is, on a high level, this is what you can deliver them as a data scientist. And sometimes e-commerce, I really like e-commerce companies because they are so simple businesses, and they usually just want more money. They know what their product can do, and they are a very, very conversion focused business types. They just want more money. Startups, on the other hand, they like more like this ideal world concept where they change the word. They want more customer success. Because these two things are highly correlated, it doesn't really matter. But as a data scientist, you have to know that when you go to these companies, they don't want machine learning models from you at the end of the day. They don't want nice dashboards from you at the end of the day. They want these on the long term. And of course, the tools that you can provide them are actually machine learning models, but this is their focus. The stack. So there are a lot of questions as well that I get, that what is the best tool a data scientist have to learn? What is the number one tool that I don't know, that you can learn before you get your first job? And actually, there is no such a thing that the best tool or the most often used tool. Just in these few projects that I've worked on in the last year, I've used a lot of tools, and these are just a few that I quickly could put on this slide after opening a few notes from the project. But the point is that, for instance, when I started to work for one of these companies, I knew that they use Google BigQuery, which is essentially Google's own SQL tool. It's a little bit different from um, from PostgreSQL that I've worked a lot with before, but I knew that I don't know Google BigQuery. Regardless, I knew that that's an SQL tool, and I told them that okay, I don't know Google BigQuery per se, but I'm pretty sure that I can learn in like 1 or 2 hours, and because I was upfront about it, and I actually knew that I can learn this very fast, and I was curious about how Google BigQuery works. That wasn't an issue at all, but my point is that when you start a project, nobody expects you that you will know the exact stack, every tool in the stack they use, every little tool. They expect you to have and what you actually have to have, that you have like a strong SQL skill. Doesn't matter which tool you used before, like PostgreSQL, MySQL, SQL, Microsoft SQL, SQL Server, or Google BigQuery. Doesn't matter. The point is that you have used SQL, and after that you can migrate your SQL knowledge to another platform. The same goes for Python. It doesn't matter what is the exact stack or the exact framework that you have used for Python. You will have to know Python. After that, you can learn any other part of it. And the same goes for data visualization. So if you know these three things, an SQL language, Python, and the data visualization tool, it doesn't really matter which exact tool you used. Of course, in the Junior Data Scientist first month course, I picked the tools that I like the best. So there we use PostgreSQL, we do Python in Jupyter notebooks, and for data visualization we use Data Studio. But again, on the job I had to learn quite a few tools. Like for instance, I never used Power BI before, but I had to learn, and I learned it very easily. And my point with this is that once you have the solid basics of coding, the basic data science skills, soft skills become more important than these hard skills. So it's more important that you have a solid business understanding, you have good negotiation skills and people skills, you can ask the right questions, and the most important part is that you can learn fast. Because when you start with a new company, or as a freelancer or as a full-time employee, you have to learn really fast their business model, right? So it's every time you start at a new company, it's a different business model, but if you can learn that fast, that's a big advantage. You have to learn the different fields, you have to learn the company structure, and as I said, you always have to learn new tools. So learning fast is, after you have the solid basics, learning fast is one of the most essential skills that you can have as a data scientist. Okay, and here comes a few musts that I talked about. So for instance, the most often used Python function or method by me in the last quarter was the .core function. And if you haven't used this, it calculates the correlation between two parameters. You have this in Excel. If you used correlation calculations in Excel, it's almost the same, but it's in Python, of course, and it's a bit more user-friendly in Python, and it has more statistical nuances in it. The point is that I used this .core function a lot in the last quarter, somehow, accidentally, and so I always said that correlation between two parameters is not that important. You might have heard that correlation doesn't imply causation, right? So just because two things are correlated, it doesn't necessarily mean that they have a direct cause-effect relationship between them. But what I have learned in the last quarter, that correlation is important from another perspective, because if you can discover that you do not have correlation between two things, that's another important finding. And once you discover that you didn't have correlation between two things, that means that that you actually disproved a hypothesis, which is part of the data science journey, right? So you have to refuse a lot of hypotheses to actually accept another hypothesis. And during this last quarter, I have done this a lot. So I checked out correlations, and like 95% of the time, or even more, I found that, okay, we do not have correlations between these two parameters. And I had some pretty surprising correlations, like, for instance, for this web shop e-commerce store, I had a strong suspicion that there is a high correlation between customers reading a lot of articles and purchases. So I said that I suspect that if a customer reads more than 10 articles on the blog of the e-commerce store, they will highly likely purchase something from this e-commerce store, because that's what they say. High engagement usually means high commitment to the company. But in this case, it wasn't true. They were uncorrelated. There wasn't any correlation between these two numbers, and we had a lot of these things. So we disproved many connections that we had a strong suspicion before this research. So that was interesting. And after we had like a few correlations that were actually strong correlations, we found a few cause-effect relationships as well, but it was a very long process. So it was really interesting, at least for me. The biggest headache was, wait for it, communication. So I haven't had any annoying bugs in the last quarter. I haven't had any data cleaning issues, automations issues. You know, the tools, the computers are really friendly. If they have a problem, they tell you in an error message, and they also tell you what you should do to fix that problem. Well, humans are a bit different. So I'm not saying I had a lot of communication issues, because in the last few years I sort of learned that part as well. But every time you go to a new company as a freelancer, you will have to adapt to their communication channels, for instance. So there are companies who prefer to do the communication via email 100%. There are companies who do that on Slack via chat. There are companies who do stand-up meetings every day. And you, as a freelancer, you will have to adapt to these communications priorities at every company. And you know, that was really interesting for me as well, that my biggest headache, or the biggest problem, was this communication part. Of course, you can easily overcome this. You just have to learn how these companies works. So let's talk about the most unexpected finding last quarter was that your funnel looks good on paper only. So there are these business books. If you have heard about funnels, then you know that there are these business books who teach you how an ideal funnel looks like and how you can analyze funnels. Like, for instance, here's a hypothetical one. The first step in your funnel is website visit. Then the reader or potential customer goes ahead and reads an article. Then they download your free stuff, then they pay for your paid stuff, right? This is how e-commerce businesses work. This is how online education businesses work. This is how software as a startups businesses work, and this is how an ideal funnel looks like. Well, the problem is that as I found that real life funnels don't look like this. So usually when you sketch this on paper, it looks like this. But when you actually analyze the data, you will find that, okay, there are people who visit your website and go straight and pay for your stuff. Very good, of course, but it messes up your funnel. Then there are a lot of people who comes for your free stuff. They download it, and after that they start to read articles, and when they read articles, then they pay for your stuff. So it's very confusing, and I'm a little bit. I start to think that funnels do not really work, and they are only mental models for business decision makers. But in real life, funnels do not work like funnels. It's more like connected dots, and people go from here to there. But it's most usually, based on my analysis at least, it's not like a straight way from low commitment to high commitment by users. They go everywhere. The most unexpected finding, number 2, it's very hard to find strong correlations. And I actually talked about this at the .core Python method, but I just wanted to mention this one more time, that it's, as a data scientist, it's your job is like 99% of the time is it doesn't really bring an immediate win, right? So people expect from you, when you go to a company, that you will analyze the data and you will find the gold right away. But finding the gold is not that easy. So you will have to dig a lot and to find things that don't work. So you say that, okay, we have expected that these two things will correlate. They don't. We have expected that these two things correlate. They don't. And you do this like 9 out of 10 things until you find something that are correlated. But then you will realize that, okay, these things are sort of heuristics that they correlate. So for instance, you say that you find that, okay, I found that paying users use paid features more than free users. That's an interesting correlation, but not really useful, because we already knew that. And so what I have found, that around 2 or 3% of your findings will be actually useful, interesting, and unknown findings. And that's true for correlations as well, but any other part of the job, just in general. The biggest win, this was an interesting thing, because for this analysis, I got the inspiration from the Junior Data Scientist first month course, because one of the students, like years ago, sent in his solution for the final test task, and he used a very similar method. And at one of the clients years later, I realized that we can apply his very creative problem-solving method, and this is what we have done. We calculated buying probability for each and every visitor of the website. So we use the classification method. Well, I use the classification method based on the different customers. This was for the e-commerce store. So these customers visited different articles, right? And based on that, we could compare those users who didn't buy anything yet to those users who have already bought something. And if we have seen a similarity between the pattern of the users who bought something and those users who didn't buy anything. We found like a strong similarity between those. We could have said I used the random forest model for this, but that's not really important. The point is that we found that there are users who didn't buy anything, but actually based on our model, they have like a 90% probability that they will buy from us. Or they have an 88% probability, and so we could have created a priority list, and based on this priority list, either sales could have contacted that person, or we could have shown a pop-up for these users on the website, or if we had the email address of these users, we could have emailed these users, just because we knew that they are really similar. They didn't buy, but they are really similar to those users who have bought something. So this was really interesting, and it worked really well, and it was very low-hanging fruit, and I'm really thankful for that old JDS student who actually gave me the inspiration for this method. It was a really cool one, and the client pretty much liked it as well. And the final one, the most interesting tool that I have learned, it was Network X, which I have used for cross-selling analysis, also for the e-commerce tool. So we analyzed, it's a clustering method. We analyzed that for each product, so these nodes, like for instance the green nodes, are different products that customers bought on the website. We analyzed that customers who bought this product 19, what else they bought, and every time we have seen that, for instance, a user have bought product 19 and product 9 as well, we put an edge between the two numbers, and of course the more users had bought both products, then the edge was stronger and stronger. And you get the point. So we created clusters based on that, where we had strong edges between the nodes. Those nodes became a cluster, and as you can see, we have created 1, 2, 3, 4, 5 clusters, and we have found that which products are both together likely, so we could create more efficient cross-selling offers in this e-commerce store. So it was really interesting, and it's not because the method, because cross-selling is nothing new, but because I had to learn the Network X Python tool to create this analysis, because other clustering tools didn't really perform well. So I checked out this Network X tool, and it worked really well with the data we had in this store. And this was completely new for me. I didn't do anything graph-based before, but it wasn't that hard to learn. And that's what I said at the beginning of this webinar, that once you know the basics of Python, learning a new tool or a new library, it's not that hard anymore. What I have done is that I copied the code from the tutorials that they had on Network X's website, and then I tried to tie it to our needs. And after a few hours of work, it just started to get together, and I understood how the tool works, and it started to produce useful results for us. So it was really interesting, and it's a good tool. I never used it before and after, but it was good to learn how these things work. So all in all, I just wanted to show you a few interesting things about what I have learned in Q4 in 2022 based on the projects I worked on. And my finding, or my general finding, is that the tools that you learn are not that important. The important thing is that you have the solid basics, SQL, Python, a data visualization tool, And once you have these, it doesn't really matter which exact tool you use or learn. What matters is that you have the soft skills, you know how businesses work, you can learn fast, and if you have all these, you just have to do more and more projects, and you will become more and more senior data scientist. So this is how it works. And at this point, I think I'm done with the presentation I prepared with. So these were few data science projects I worked on in 2022, and I just wanted to show my findings. This is where I will cut the video and I will publish this part. And this is where comes the Q&A session. Before that, let me promote one last time the Junior Data Scientist first month course. I will open registration for it at 10 p.m. Central European time, so in 18 minutes, 18 minutes. If you haven't checked it out, go ahead and check out data36.com/JDS. This is the course that will teach you the basics, just what I talked about, how to use SQL, how to use Python, how to use a data visualization tool, how to clean the data, how to automate the stuff, your stuff. And it's a 100% practical online course, so it's practically a simulation of being a junior data scientist at a true-to-life company. It's one big case study that will drive you through everything. So I think it's a pretty cool course. I thought about a lot already, so I won't talk about more. One last time, if you want to check it out, data36.com/JDS. And let's talk about your questions.